G'day everyone, welcome back to Beast Lab. Today's episode is number 2 in the tutorial series. We're going to do some more programming with the Mega board. So stay tuned, we'll show you what we've got in store. This is the next lesson in the tutorial series. It's called LED. Here's a list of the parts we need. We need the Mega board, a red LED, one 220 ohm resistor, one 1000 ohm resistor or 1k ohm, and one 10k ohm resistor, and also the male to male jumper wires. I'll go and get those parts out now, lay everything out on the board, and we'll put that circuit together. This is the main component of putting the circuits together quickly on your bench. This is called a breadboard. You see here, all these paths are joined. Each of these lines, there's 5 in a row there, and they're all joined together in a straight line. And then you go from this pin here to that pin here, and there's a break in the middle, and then these are also seriesed up here. So all these pins are one bridge, all these pins here are another bridge, and that goes all the way across the board. There's also another row of pins along the side. These are used for your positive and negative rail, and those pins are common all the way along top and bottom. Here's the first component of that circuit. It's a red LED. The positive side of the LED is called the anode, and the negative side is called the cathode. To have this supplied by the Arduino, you've got to make sure that it doesn't burn out. So this LED is put in series with a resistor. It says it there, it's a choke, and it limits the amount of current flowing. So we put a 220 ohm resistor in series with that cathode, back to negative, and that reduces the voltage across that LED, and then it won't blow up, and we can use it straight off the board. Here's the resistors we were talking about. These limit the flow of electricity, or the flow of current in an electrical circuit. These coloured bands tell you what the value of the resistor is. We'll go into that a little bit later. But for now, it's pretty easy to just pick your resistors from the packet. They're all labelled, so you grab what you need and go ahead and build the project. If you take a look at the diagram here, the circuit runs from 5 volts over to your 220 ohm resistor, and connects to your red LED, and then over to ground. Now take a look at the board. Got our 5 volts here, and that'll connect to the resistor, then onto the LED, and back to your ground pin, which is either those 2 pins there with the G and D there. And here's the wiring diagram. You see those pins on the board correspond to that diagram, and then we've got the breadboard below that. So the 5 volts comes out, and along this rail comes to this resistor. They've choked the resistor on the anode, so they've put that on the positive side, and then the negative side, the cathode, goes back to ground. At the moment, we've got the 220 ohm, that's in place in the circuit there. We'll build that circuit on the breadboard now. I've opened up the kit. I've got out all the resistors. You can see you get quite a few with the kit. I'm going to use one of those 10k, one 220, and one of those 1Ks as well. Here's our breadboard. grab the jumper wires. You get the male to male jumper wires, you get a heap of them. And you also get a male to female set as well. This comes in a ribbon, they're all joined together. I just chose to strip them apart. You can just run them however you like then. I've selected one of the 220 ohm resistors. I've shaped the legs into a U shape there. That's just so you can press it into the breadboard easily when you're completing the circuit. We'll quickly go through the color chart for the resistors now, just so you can tell the value of the resistor, if it's out of the packet or if you just have a random one laying around. You can see on the diagram there's a 4-band code and a 5-band code. Because we're working with 5-band resistors, we'll just stick with the diagram on the bottom there, the 5-band code. Here's the 220. If you look there, it's red, red, black, black, brown. So that'll be 220 for the digits and the multiplier of 1, so that's 220. And then the tolerance of 1%, that's the last brown band there. So say you read that 220. The next resistor is that 1k ohm resistor, which is 1000 ohms. And here we have the code. Brown, black, black, brown, brown. So it's 1, 0, 0, and then a multiplier of 10. So 100 times 10 is 1000. And then a tolerance of 1% because of the last brown band. The last resistor we use for this project is the 10k, or 10,000 ohms. Here it is here. Brown, black, black, red, brown. So we've got 100 times by 100, which is 10,000. Here's all the parts. Now we can build the circuit. Grab that red wire first. We go from 5 volts on the Mega over to the positive rail of the breadboard. So now this entire row here is positive, all the way from one end to the other, just on that first rail next to the red line. Do the same with the black wire now. A wire from ground on the board over to the negative rail of the breadboard. So now that entire rail next to the blue line is grounded. Now we take your LED. We've got to make sure we get the polarity correct. We take a close look inside the LED. There's 2 little pieces of metal there inside the plastic. The smaller one on the left is the anode, and the larger one on the right is the cathode. You can also see here the anode has a longer leg than the cathode. That's another way to tell. There's also a flat section on the side of the LED, just across here on that bottom rim, and that corresponds to the cathode, which is the negative. Now that we're armed with all the information we need about the components we're using, we can build that circuit. I'm going to build the circuit a little bit different to the wiring diagram on the screen. This will help you understand the breadboard a little bit better as well. So I'll put that LED in first. We know that the longer leg is the anode. You can put that anywhere at the moment. So I'll just choose there. I'll just put the anode to the left. Now we grab the 220 ohm resistor. We know we've got to go from the positive 5 volts to the anode of the LED. So this rail's all positive and the anode is on the left. So now we come off that positive rail here and run down along this line that's all commoned up into the left-hand pin of the LED. These two little rows are independent of each other where the LED is plugged in. So now we just pick up this second rail and take that back to ground. To do that, I'm going to use a second black jumper wire. We connect to that cathode and go back to the ground. You can also just go straight back to the card to ground there, either way. That just shows you how the breadboard works. These paths run along here, are positive and negative. So negative is running along here and then coming across to our cathode, and the positive is running along here through our resistor and up to the anode of that LED. Now we can plug the Mega board in. It's going to supply 5 volts over to the breadboard. That'll return to ground and the light will come on. There we go, there we go. Light at full brightness there with that 220 ohm resistor. Now we'll replace that 220 ohm resistor with the 1K and see what effect that has on the circuit. Now I'll put that 1K into the circuit. I'll turn that on. You can see there, the LED is nowhere near as bright now. There's more resistance in the circuit due to that 1K resistor, 1000 ohms. It's restricting the current flow through the light, so you get less light coming out of the LED. Now I'll replace that 1K resistor with the 10K resistor and we'll check out what that does. Here's the 10K. Just fold those legs over. Connect one side to positive and the other to the anode and turn that circuit back on. There you go. It's very dull now, restricting even more current flowing through that LED, so nowhere near as much light coming out. So that's the purpose of a resistor, to restrict the flow of electrons in a circuit. So it was a great little project. We've learned about resistors and LEDs and what that resistance does to the flow of electricity on a circuit. So I'll go into the next lesson in the next episode. Base Lab, stay tuned to Base Lab. There's plenty more to come. Take it easy, guys. Have a good one.